Hey guys, this lesson is some little tricks on memorizing parts about the unit circle. So it's not everything, but they're just some gimmicks that I teach in my class. So here we go. So here's our unit circle in degrees and radians right here. Okay, so remember from the last lesson, you guys, we can do it, the degrees are in the inside, so 0 degrees all the way to 360 right here. And then radians are on the outside, so I'm sorry, 0 to 2 pi right there. Okay, so what I'm going to do is cut this circle up into 24 equal pieces right there. Okay, so let's deal with the degrees first. So 360 divided by 24 is 15. So if we just add 15, 15, 15, you guys with me? Okay, so if we just keep doing that, there's that quadrant, and then there's that quadrant, and finally the fourth quadrant is right there. Okay, so if we take uh, 2 pi, you guys, and divide that up into 24 right there, then 2 pi divided by 24 is pi over 12, okay? And then, well, think of this, you guys. If this is 2 pi and this is pi right there, and it's 24, we cut them up right there, then the top half, we cut it up into twelfths right there, okay? So if this is pi, this is 1/12 of pi, so it's pi over 12. So that would be 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12. See how this is 6 pi over 12 reduces to pi over 2. Let's reduce this guy. So 4 goes in here once and here 3 times. 3 goes in here once and here 4 times. And then this is going to be pi over 6, 1 pi over 6, okay? All right, so here we go. So this is going to be, since this is 6 pi over 12, 7 pi over 12, 8 pi over 12, 9 pi over 12, 10 pi over 12, 11 pi over 12, okay? And then we'll reduce those guys right there. Okay, here's 12 pi over 12, so this is 13 pi over 12, 14 pi over 12, 15, 16, 17 pi over 12. This is 18 pi over 12, okay? So, and then we reduce those right there, okay? All right, so there's our pi in our pi family in radians right there. Well, we only want to focus on, I'm dog sitting, so you can hear my mom's dog in the background. She's kind of anxious because my mom's not here for her. Anyways, these are called the special angles, or off the x-axis. They're 30, 45, and 60 degrees off the x-axis. So it's the same pi measurements right here and degree measurements right here, but these are the ones that are dealt with in pre-calculus most of the time, are the 30-degree angles, 45 and 60 right there. And same over here. This is off the x-axis 30 degrees, off this x-axis 45 degrees, and off this guy 60 degrees. And same down here. Down here is 30. From this x-axis to here is going to be 45 degrees. From this x-axis to here is 60. Same over here. 30, this is 45, and then this guy is 60, okay? And those are all our pi measurements that we just did right there, okay? So here's characteristics of our radian measures right here, okay? So moving from the x-axis and these special angles right here, the denominators go, moving away from the x-axis, this denominator goes 6, 4, 3. Same with this one, from the x-axis, 6, 4, 3. You see how the denominators are 6, 4, 3, 6, 4, 3. So from the x-axis, it goes 6, 4, 3. Okay, in quadrant 1, they're all pi over 6, pi over 4, pi over 3. In quadrant 2, the numerator still has pi. They all have pi's, but the numerator is 1 less than the denominator. If that's 3, then that's 2. If that's 4, then that's 3. If that's 6, then that's 5. Look at these numerators. The numerators in quadrant 3 are 1 more. Okay, in quadrant 4, it's kind of harder to see, you guys. But if I doubled this number, 3, and took 1 away from that, so double that is 6, 1 off of that. Double that is 8, 1 off of that. Double 6 is 12, 1 less than that. So it's 1 less than twice, okay? That's what happens in quadrant 4 right there. Okay. So this was the first section that we did in our class, section 13.1. Okay, so we had 30, 45, 60 degree angles right here. So let's just look at this 30 degree angle right here. So the sine of this 30 is opposite over hypotenuse. So it was 1/2 right there. Okay, the cosine of this 30 right here was, here's the 30, adjacent over hypotenuse. So that's where we got root 3 over 2. The tangent of 30 was 1 over root 3, which we multiplied by root 3 over root 3 to get root 3 over 3. Okay, and then 45, so the sine of 45, here's a 45, so it was opposite over hypotenuse. Same with cosine, except it was this adjacent over hypotenuse. The tangent of 45, opposite over adjacent, so 1 over 1. So 60, we do the same thing. Sine is opposite over hypotenuse. That's where we get root 3 over 2, okay? So remember, and this was off of 30, 60, 90 triangles that we did, and 45, 45, 90 triangles in section 13.1. Well, 30 degrees, you guys, let's go back to our circle right here. 30 degrees is the same as pi over 6. 45 degrees is pi over 4. 60 is pi over 3. So these also work for radian measures right here. So the sine of pi over 6 is 1/2. The cosine of pi over 6 is root 3 over 2, and the tangent of pi over 6 is root 3 over 3. So these are all the same right here with our radian measures right there, okay? So the trick to remember these, you guys, is first of all, we got a note. Let's go back right here. This helps me. It's my gimmick. So if we got root 3 over 3 because it gave us it was 1 over root 3. Okay. So let's go back to this right here. So the 30-degree angle right here. The tangent of this 30 is opposite over or adjacent. So 1 over root 3, and that gave us root 3 over 3. So first of all, let's recognize that root 3 over 3 came from 1 over root 3. So if we just kind of mentally put that back in there, it's going to help us with a gimmick right here. So this is what I do, you guys. The sign goes, all the numerators go 1, 2, 3, and they're all square roots, you guys. The square root of 1 is 1, so I don't need the square root there. Here's square root of 2, here's square root of 3. Okay, look at the numerators, 1, 2, 3. Okay, and they're all square roots. Well, that's square root of 1. You don't need that there. And they're all over 2. Okay, look at the cosine, you guys. They go 3, 2, 1. So the cosine follows the pattern 3, 2, 1. All square roots, you guys. And then the tangent follows the pattern 1/3, 1, root 3. Okay, 1/3, 1, 3. And they're all roots right there. Square root of 1's 1. Okay, square root of 1's 1. So 1/3, 1, 3. Those are the gimmicks that I do on that. So cosecants, you guys, is just the reciprocal of sines. So the cosecant of 30 degrees is 2. The cosecant of 45 degrees, this came from 1 over root 2, so the reciprocal of 1 over root 2 is root 2, okay? And then the cosecant of 60 degrees would be 2 over root 3, which is 2 root 3 over 3, okay? And then the secants are all the reciprocals of the cosines, and the cotangents are the reciprocals of the tangents. So if I just reciprocate these, I think that's a word, we get those guys right there, okay? So remember, the 30 goes right here, which is the same as pi over 6. 45 is pi over 4. That goes in this area right here. And then 60 is pi over 3. That gives us our cosecants, our secants, and our cotangents. Okay, stuff that we did in section 13.1. So evaluate the trig functions and give exact answers if possible, but you may need to use a calculator. So we'll use the calculator if they're not are special angles, the 30s, 45s, and 60s, or pi over 6, pi over 3, pi over 4. Okay, so here's cosine of pi over 4. That's a special angle right there. Remember, sine goes 1, 2, 3, cosine goes 3, 2, 1. Okay, square root of 3, square root of 2, square root of 1. So this is going to be root 2 over 2. Okay, root 2 over 2. Okay. And then tangent of pi over 3, okay? Well, tangent goes 1/3, 1, 3. So they're all square roots. So remember, it goes, for the radian angles, goes 6, 4, 3 away from the x-axis. So pi over 3, we're looking at this one. So this one's the square root of 3. Okay, easy. All right, once you get the tricks down. Okay, the cosecant of pi over 6. Well, pi over 6 is a special angle right there, so that's the reciprocal of sine. So we have to find the sine of pi over 6 first, and then do the reciprocal of this. So the reciprocal of 1/2 is 2. Okay, how about this one? The secant of 4 pi over 15. Okay, this is not a special angle, so we got to use a calculator right here. Okay, let's first find the cosine of 4 pi over 15. Okay, so we just have to use our calculator and make sure that you're in radians. It should say RAD, not DEG. DEG stands for degree. You'll get the wrong answer if it's not in radians. Okay, so let's first find the cosine 4 pi over 15. So when we punch that in radians, I got 0.669. So if you hit your 1 over x button, or just do 1 divided by that number right there, so when you reciprocate that, you get the 1.494. Okay, you guys, if you're in my class, that would be your assignment. Take care.